Welcome to another work example with Dr. Schleif. You can see that we're looking at question number 22 here from paper 1, which reads the period of an electromagnetic wave is 1.0 ns, whatever that means. What are the frequency and wavelength of the wave? All right, let's jump over to the chalkboard here and continue our work. So they tell us the period, they tell us it's an electromagnetic wave. Students of physics will know that that means that it's light. And light always goes at a certain velocity, constant velocity c, and it's approximately 300 million meters per second. So we can use that velocity. If we have any clue that it's light, you already know the speed. Light always goes at the same speed. And it's actually equal to 299,792,458 meters per second, 299,792,458. Which is actually coincidentally the PIN number to my bank account, but it's also the speed of light. We just round it to 300 million. You don't have to know the sort of the precise value. In fact, I should probably erase that off the board. Don't worry about that. Forget what I said. 300 million. All right, so this lowercase n here means nano. So we know that the time that it takes the electromagnetic sort of field to oscillate is 1 nanosecond. We mentioned in a previous video that students of physics, especially in ACE physics, they should know their metric prefixes in the order of 10 that they represent. So I'm going to rewrite this time period t as 1 nanosecond, where nano is a billion, so 1 × 10⁻⁹ seconds. In order to calculate the frequency, we simply take 1 over the time period, right? So 1 divided by a billionth is a billion, right? It's a billion. So I think that's just going to be 10 to the positive 9 hertz would be the frequency that should be typing in calculator. 1 over 1 billion is a billion, right? We're dividing by a billion, we get a billion. And then to calculate the wavelength, again, we know what the velocity is, and you may recall that velocity is equal to wavelength times frequency. So once we've calculated the frequency is 10 to the 9, a billion, we know the velocity is 3 × 10⁸. So these are reciprocal seconds, same thing as hertz. These are meters per second. We're solving for the wavelength lambda. Divide by a billion reciprocal seconds. By a billion reciprocal seconds. All right, so what is 300 million divided by billion? .3 meters. All right, so 30 centimeters is the wavelength. Does that be like what, like a microwave or maybe a radio wave? Yeah, so 1 gigahertz, right? That's what we calculate it to be. So pretty straightforward. Given the time period, you can always calculate the frequency without knowing the speed. But in order to get the wavelength, you do have to have some other clue, like what is the velocity? The clue that we have in this question is that it's an electromagnetic wave, otherwise known as a light wave. Let's go back to our answer choices and see if we find something that agrees with that. And so we can see choice C there, 1 × 10⁻⁹, a billion hertz, 0.3 meters of wavelength. And so choice C seems like the reasonable answer here. But let's check question number 22 in the mark scheme. So as you study for your ACE Physics paper 1, previous papers are a great resource, but always give yourself feedback by looking at the mark scheme. And indeed, question number 22, choice C. So good work, everybody. We'll see you next time.